Hey there, everyone. Today's lesson in personal finance is more or less the last lesson of Unit 2, Good Interest and Investments. Up to this point, we've been working primarily with one-time investments and calculated the growth of that one-time contribution to an account over time with simple interest and then various forms of compounding. But we haven't really considered a more realistic situation. Hopefully it's more realistic for you in your life, and that is continuously putting money into the account and what that does to the growth. And this adds a little bit to the complexity of the calculations, but fortunately, this is a math class and we have a tool for that. And I'm going to show you that tool today. This is an introduction to the mathematical concept known as summation. So summation is symbolized, like many things are in mathematics, by a letter. And this particular letter is a Greek letter, and that is the capital letter sigma. You may have seen it before. Sororities and fraternities and other places. It's nothing more than a letter, and it represents something in mathematics. And the concept that it represents is summation. So when we build formulas, we know what this concept is asking us to do. It's asking us to add something. Remember that the root word of summation is sum, and a sum is to add, or the result of an addition problem. So how does this work? Well, we're going to add a little bit to this symbol, and I'm going to start with a simple example. Typically, you'll see the sigma, capital sigma. Below the sigma, you'll see either N or X or I. I'm going to use N today. And it's almost that letter N or X or I equals 1. And that just represents the starting value that you're going to input into an expression. And I'll show you that expression in a minute. And you'll also see something on top of the sigma, and that represents, I'm going to put a 3 up here for now. That represents the ending value that you'll plug into your expression. So we're going to start by plugging in a 1, then we're going to plug in a 2, and then we're going to finish by plugging in a 3. And the sigma then says, add the results of those 3 plugins, so to speak. Now, what are we plugging them into? Well, that's what goes out here in front of the sigma. So in this box, you don't have to have a box there, I'm just putting it there for our purposes today, will be some sort of an expression that you plug the numbers 1, 2, and 3 into. It's kind of like a function. I'm going to put a simple one in here. 2n. 2 times whatever you plug in. And that's it. That's a simple version of a summation problem that I'm going to translate for you and do the operations. The first term will be 2 times 1. The first thing we do is plug in the 1. Now that big Greek letter sigma just says then to add the next term. The next thing we're going to plug in is a 2. And we're going to add the next term. And the next thing we'll plug in is a 3. And because that 3 is on top of the sigma, that means that's where we end it. 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6. And so we end up with 12. And that's the simplified version of summation. Let's try another one. In this next example, I'm going to add an exponent. So we're going to take the sum of, let's go 4 terms this time. So inserting 1 through 4, and we'll do 3n squared. So this results in 3 times 1 squared. It's probably a good idea to write these out. 3 times 1 squared plus, that's what this big summation symbol tells us, 3 times 2 squared plus 3 times 3 squared plus 3 times 4 squared. If you can't do this in your head, that's okay. I'm going to work this out. Remember, order of operations. We have to do the squaring before we multiply by 3. So 1 squared is 1 times 1, that's 1. And 3 times 1 is 3. The next one, we square the 2 first. 2 squared is 4 times 3 is 12. 3 squared is 9 times 3 is 27. And 4 squared is 16. 16 times 3 is 48. Now to add these 4 numbers in my head, I would look for easy ones to add, like the 12 and the 48 make 60, and the 27 and the 3 make 30, and 60 and 30 is 90. And that's how you handle summation. Let's do one more example. We'll add one more wrinkle this time. Okay, this time I'm going to add a multiplier that continues to be included in the summation, and you'll see it written as, let's go 3 terms. Sometimes you'll see it written to the left of the summation symbol, so I'm going to write 100 out here to the left. Sometimes you'll see it written to the right, and actually either one works. So if I include it here, and then you write the rest of the function, and that 100 will get attached to each term. I'm gonna use the one written on the left here, so I'll get rid of this guy so I have some room. Okay, so in this one I'm going to try to simulate an investment calculation based on annual interest. So let's assume we're going to invest $100, but we're going to continue to invest that $100 for 3 consecutive years. So every year we throw $100 into an account, and that account is growing at 9% annual interest. Like I said, it's for 3 years. So if we can continue to add the $100, then it's not just a one-time investment of $100 that grows at 9% for 3 years that we know how to calculate. This is a repeated investment of $100. But the formula is still the same. So to the right of the sigma, I still write my 1 plus 9%, that's 1.09. But this time my exponent is actually the number of years. Well, it has been the number of years, but now it's coming from this 1 and then changing to a 2 and then changing to a 3 to represent 3 years of growth. So let's see what that looks like. Like I said, the 100 gets attached. So I end up with a 100 times 1.09 to the first. Remember that 1 goes in for n. The sigma says add the next term. The 100 gets attached times 1.09 to the second plus 100 times 1.09 to the third. If that was 20 years, you would have 20 terms. If we had monthly compounding, we would build the formula such that it divides the 0.09 by 12, and then we would increase that number on top of the sigma to represent the number of months that the money grows. And we'll work on problems like that. So I'll be right back with the answer to this problem. I know you're burning with curiosity. Okay, I went to my handy-dandy Desmos calculator, and the answer to this comes out to 357.31. And it was working with dollars here, so that's going to be $357. So how much money did we put in to make that 357? Well, we put 100, another 100, and another 100. So $300 investment, that means $57.31 in interest. I hope this helps begin your understanding of summation, and especially summation in terms of personal finance. We'll be working more with it the next couple of classes, and we'll talk to you soon. Take care.